Welcome back to chapter 3 of our data communication course. This third session where we will explore unguided media, the world of wireless communication. In our previous session, we examined guided media such as a twistor pair, coaxial cable and fiber optic. Now we will turn our attention to transmission without physical conductors where signals are broadcast through free space. We will cover the fundamental characteristics of a wireless transmission, propagation modes, the electromagnetic spectrum, and the three main types of unguided media, which is the radio waves, the microwaves, and infrared. Let's begin with the basic concepts of a wireless communication. Unguided media transport signals without physical conductors, meaning the signals are broadcasted through free space using electromagnetic waves. Wireless transmission can be omnidirectional, broadcasting in all directions like radio, or unidirectional, using narrowly focused beams like microwaves. The medium for wireless communication is simple air and space, which serves as the channel for signal propagation. One important consideration is security. Wireless transmission is generally less secure than guided media because signals can be intercepted by anyone within the range. Understanding these fundamental characteristics is essential for designing and implementing wireless communication systems. Now let us examine the three primary propagation modes for wireless signal. The first is ground propagation, where signals hug the Earth's curves. This mode is typically used for frequencies between 2 MHz and allows signal to follow the contour of the Earth, making it suitable for long-distance communication at low frequencies. The second propagation mode is sky propagation, where signals are reflected off the ionosphere, the layer of the Earth's atmosphere that contains charged particles. This mode operates in the frequency range of from 2 to 30 MHz and allows for a greater distance by bouncing signal between the Earth and the ionosphere. The third propagation mode is the line of sight or loss propagation, which involves a straight line from the antenna to antenna. This mode is used for frequencies above 30 MHz and is affected by the Earth's curvature, meaning that antennas must be high enough to maintain a clear line of sight. To understand where different wireless technologies operate, we need to look at the electromagnetic spectrum, which is divided into frequency bands with distinct characteristics. The very low frequency or VLF and the low frequency LF bands range from 3 to 300 kHz, use a ground propagation and are used for navigation. The middle frequency and the high frequency MF and HF bands from 300 kHz to 30 MHz uses for sky propagation and used for amplitude modulation or AM radio and citizen band radio. The VHF or very high frequency and the UHF ultra high frequency bands from 30 to 3000 MHz uses both sky and line of sight propagations are used for frequency modulation or FM radio, television and cellular networks. The SHF and extremely high frequency AHF bands from 3 to 300 GHz use line of sight propagation and are used for satellite and radar systems. Each band has its own propagation characteristics and applications, making the spectrum valuable resources that must be carefully managed. Now let's explore each type of unguided media in detail, starting from the radio waves. Radio waves operate in a frequency range of from 3 kHz to 1 GHz. They are omnidirectional, which means they transmit in all directions and antennas do not need to precise alignment. This makes radio waves ideal for broadcasting to multiple receivers simultaneously. Low and medium frequency radio waves can penetrate buildings, provide coverage indoors. Radio is ideal for multicasting applications such as AM and FM radio and cordless telephones. However, the entire radio band is regulated by authorities such as the FCC, which allows frequencies to prevent interference and ensure orderly use of the spectrum. Next, let we examine the microwaves, which operates in the frequency between 1 GHz to 300 GHz. Unlike radio waves, microwaves are unidirectional, using narrowly focused beam that require antennas to precisely align with each other. The two main types of microwave antennas are the parabolic dish, which has a funnel style that focuses signals into a narrow beam, and the horn antenna, which has a scooped shape that connects direct signals. Microwaves offers high data rates because their wide bandwidth allows for faster digital transmissions. Common applications include the cellular networks, satellite networks, wireless local area networks. The directional nature of microwaves means that they are well suited for point-to-point communication links, such as connecting buildings or providing backhaul for cellular networks. Finally, let us explore the infrared transmission, which operates in the frequency range between 300 GHz to 400 THz. Infrared is short-range wireless technology that cannot penetrate walls, which prevents interference from neighboring devices. However, it is useless outdoors due to interference from solar radiation, which contains significant infrared energy. The infrared port is standard for infrared communication used in devices such as keyboard, for mice, and printers. The original data rate was 75 km per second, but it has now been upgraded up to 4 megabits per second. Infrared is a simple, low-cost solution for short-range, line-of-sight communication between devices in the same room. To summarize this session, we have explored the world of unguided media in wireless communication. We learned that wireless communication occurs through the air and space, with signals being either omnidirectional or unidirectional. We examined the three propagation modes: ground, sky, and line of sight, and how they relate to different frequency bands in electromagnetic spectrum. We then explored three main types of unguided media: the radio waves, which are omnidirectional and penetrate buildings; the microwaves, which are unidirectional and offers high data rates; and the infrared, which is short range and cannot penetrate walls. Each type has its own advantage and limitations, making them suitable for different applications. This concludes our coverage of Chapter 3 on data communication and transmission media. Thank you for watching, and I look forward to see you in the next chapter.